Here's our last lesson to do with vertex form of a quadratic. This is just where we put it together and then look at how it relates to the graph and maybe solve a few problems to do with it. So to calculate the initial value of a quadratic relation, we want to, well, let's just backtrack for a second. Initial value basically means the y-intercept. Okay, if we're thinking about the graph, we're thinking about the y-intercept. And the y-intercept occurs when x equals 0. So if I have a graph, and just I'll randomly sketch one, let's say it looks like this. The initial value is the y-intercept, and the reason why it's called the initial value is because oftentimes we only deal with this part of the graph, right? In quadrant 1, we often don't say it was a time thing. We wouldn't use the negative part of the graph to the left of that. So anyway, it's the y-intercept, and the y-intercept occurs when x equals 0. So anywhere on this line here, anywhere on the y-axis, the x-coordinate is always 0. So if I want to find out what the y-intercept is for something, if I have the equation, it's a simple matter of putting 0 into the equation and then solving it for y. So that x equals 0, and what we get is y equals -2 times 0 squared plus 3 times 0 minus 5. What you'll notice is that this is what's called standard form of a quadratic. This is not the vertex form we've been working with over the past few days. Standard form, anywhere there's an x, that term's going to disappear. So 0 squared is 0, multiply that by -2, it's still 0. So that term's going to go away. 3 times 0 is still just 0. The only thing that's ever going to be left is just this number on the end. Just a reminder, you've seen it before, but not recently. Standard form goes y equals ax squared plus bx plus c. And if it's in standard form, the initial value, the y-intercept, is always just going to be the c, the standalone, the one that doesn't have an x with it. So the initial value in this case is -5. That shows why it's the case, but I could just glance at this equation and tell you it's -5 because I know that. Now this one is not in not in standard form. It is in vertex form. That's not true, what I just said about the c value. Well, there is no c value. So in other words, it's not going to be +3. It's not going to be this number here because that's our k value. That's a different thing. But we can still let x equal 0. Let's do it in blue. Let x equal 0 and work it out. Just, it takes a bit more work. Not a lot, just a little bit. And again, following order of operations, 0 minus 4 is -4. -4 squared. Anything squared is positive, so it becomes +16. Then I multiply by the 0.5 order of operations. That gives me 8. Then I add 3. And again, it's not a lot of work, but it is a few more steps. The initial value in this case is 11. For each parabola, identify the x-intercepts and the maximum or minimum value. Oh, there's a couple other things. X-intercepts, y-intercept, maximum or minimum value, and the coordinates of the vertex. Okay. Well, x-intercepts are where it crosses the x-axis. So let's do that in green. X-intercepts, I'm going to say just like that, are 1 and looks like 5. Really hard to read the scale. So you can write it like that, 1 and 5. Don't write it like this, because that looks like an ordered pair, 1, 5, which would actually be a point up here. This is the point 1, 5. So don't write it in brackets like that. That would be a bad thing to do. So you can write 1 and 5, but not in brackets. It means something different. Oh, y-intercept. Well, this one's a little bit trickier because we can't see the y-intercept. So what can we do? We can figure out what the pattern is. in this case, I can see if I start at the vertex, which is down here at the bottom, do that in purple, and if I go over 1 up 3, then that means that my a value has to be 3, right? It's been stretched by 3. So my step pattern must be going 1, 3, 5, turn, 1, 3, 5, etc. times 3. So the step pattern must be going 1 times 3 is 3, 3 times 3 is 9, 5 times 3 is 15. So the first step went over 1 up 3, the second step went over 1 up 9, the next step has to go over 1 up 15. Again, that's off the scale, but I can see that if I'm starting here at a y value of 0, if I go up 15, I'm going to get to the y value of 15, just by the way this one works out. The y value, the y-intercept is going to have to be 15. So you're going to have to use your imagination a little bit for this one since you can't see it, but the y-intercept is 15. The maximum or minimum value. So it either has a parabola either has a maximum or it has a minimum. It doesn't have both. In this case, because the parabola opens up, it has a minimum value, which occurs at the vertex. And when we're talking about the minimum value, really what we're talking about is the y-coordinate of the vertex, because that tells us how high or low we are on the y-axis. So it's a minimum value, and that might be all the question's asking. I'm not sure if it's just asking, do you have a maximum or a minimum, in which case we just say it's a minimum since it opens up. But if I could be more specific as well, I could say the minimum value is negative 12, because that's also true. And finally, the vertex. Well, the vertex is just, we've done a bunch of those. It's the x-coordinate, which is positive 3, and then the minimum value is the y-coordinate of the vertex. So let's try it again for B part. The x-intercepts appear, this is not a good graph. I can tell right now the x-intercepts aren't quite on a line. They look like they're a little bit off these lines, which is kind of tough for us. I'm going to just ballpark it because I think that's good enough for our purposes. So I'm going to say that the x-intercepts are at -1 and +5 because they're very close to that. And I think that's all we need to know for today. So -1 and +5. The y-intercept we can read in this case. It's right there on the graph. It's at +2. This one opens down, so it's got a maximum value. And again, I'll just say what it is since it's easy to see. It's the y-coordinate of the vertex. It's at 4. And the vertex itself is the x-coordinate, which is 2, combined with the y-coordinate, or max value, which is 4. And one more example. This one's a word problem. The Windsor-Detroit International Freedom Festival hosts one of the largest fireworks displays in the world. The fireworks are set off over the Detroit River. The path of a particular firework rocket is modeled by this relation right here. Actually, I won't highlight it in yellow, but it's this relation right here, where h is the rocket's height above water in meters, and t is the time in seconds. So instead of having y and x again, this time we've got h and t, height versus time. Now in my last lesson I used yellow to highlight my a value and green to highlight my h value and orange to highlight my k value. So I'm going to stick with that because that just helps me visualize what's going on. By looking at the a value, it's negative, it's opening downwards, which makes sense. Or anything that goes up in the air and has gravity working on it is going to be an upside down parabola. So that makes sense to have the negative a value. And I can even just look at this. I can say, well, the vertex must be at 2 and 169.6. Let's draw a little sketch of it. And we can see what's going on. Always forget to change back to my pen. There we go. Okay, so we're going to stick with the quadrant 1 positive. So the firework is going to look, I don't know exactly what the graph's going to look like, but let's imagine it starting something like this and coming down like this. What we know for sure is the vertex, t is here, time is on the horizontal axis, height is on the vertical axis. So the vertex is at 2 seconds and 169.6 meters. So how long will it take to reach its maximum height? Well, when you see it like that, then hopefully it's obvious. It'll take 2 seconds. And the max height is the y-coordinate of the vertex, 169.6 meters. A firework will stay lit for an average of 5 seconds. What will the height of the rocket be 5 seconds after it is launched? So this is another case where they are giving us a variable, a value to put into a variable. They're giving us a time. So they're telling us that they want to find out what h is when t is 5. So going back to the equation, we're going to start with this equation. And then we're going to plug 5 in for t and see what happens. First we do the brackets, we get 5 minus 2 is 3. Then we square it, we get 9. Then we're going to multiply it by negative 4.9. So since we're in the decimals, let me just grab my calculator. Negative 44.1 plus 169.6. I got 125.5. So that firework's going to fizzle out at 125.5 meters. And we've all seen that. If we've been to fireworks, they go up, they start to come down, but then they sort of fizzle out somewhere while they're still up in the sky. That's the lesson. Homework is below as usual. Good luck. Let me know if you have any questions.